All right, let's continue with the second set of questions. So let's start with part A. We have the ellipse with vertices -1, 8, and -1 and -12. Okay, we have the foci -1 and 4, and -1 and 8, -8 provided for us, and we have the parametric equations for an ellipse. So we want to sort of like find h and k and a and b so that we can actually write exactly what this parametric equation is. And to achieve that goal, we need, first of all, the center, coming with the coordinates h and k. We need a and b, okay? All right, so first of all, we are given two vertices here, so we can go ahead and find the center by checking the midpoint from -1, 8 and -1, -12, okay? So again, the midpoint of two vertices is in fact the location of the center, okay? So while x coordinates are not changing here, so you're going down from 8 to -12, so the distance between two vertices is 20 units. So that half of that is going to tell you the distance from one vertex to the center. That is 10, okay? So starting from -1, 8, and going down 10 units in the y direction takes you to -1 and -2, okay? That is the very first observation. Okay, so we have h and k. How do we find foci? So how do we find c out of foci? Well, the same idea. The distance between two foci is 2c. Okay, so well, what is the distance from -1, 4 and -1, -8? Well, you're going from 4. You're going down from 4 to -8. So the distance is 12 units. So that's 2c. Out of this, c is supposed to be 6. Okay, and that's so like how you treat this. So now the question is like, how do you come up with a and b? Let's think about that. Well, since we are given two vertices, okay, the distance between two vertices on the major axis would be the length 2a, okay? So we in fact talked about that earlier to find the location of the center. So the distance between the center and each vertex is in fact what a is. So I would take this as like 10, okay? Because from 8 to -12, from 8 to -12, you have the distance to be 20. That's 2a. And to get back to a, that's exactly what you check, okay? All right, now, what is the relationship between a, b, and c? Okay, so we have that relationship c squared equals a squared minus b squared. So c squared is 36, a squared equals 100, and b squared out of this should be 64, okay? So b is supposed to be 8. All right, you're almost done. So I'm going to place h and k back in here. These are the coordinates of the center, x and y coordinates of the center. Okay, so these are -1 and 2. Okay, and I know a and b, so I'm going to go ahead and plug those back in as well. So a is 10, and b equals 8. Okay, and this is so like the parametric representation of an ellipse. All right. Let's move on to part B in this video. So you have the circle with center -1/2 and -4 and radius 1/2. So why don't you think about it? I'm going to copy the parametric representation of the circle to my next slide. All right, here's the center provided to us, -1/2 and -4, and the radius is 1/2, and this is the parametric representation of the circle with center h and k and radius r. So all I'm going to do is just place those numbers back into this parametric representation. So x coordinate of the center is -1/2, r equals 1/2. And for y, that's the y coordinate of the center, -4, and plus 1/2 sine theta. Okay, this was fast. So now I'm going to move on to part C and while I copy the parametric representation of the hyperbola, please pause the video and keep thinking what I'm going to do next. All right, so here we go. So we have the parametric representation here, h plus a secant for x, and then k plus b secant for y. And we're given the vertices and foci. So, well, first of all, the distance between the vertices is 2a. So I can see that the y coordinates of the vertices are just 1. That's fixed. And then the distance from one vertex to another is 2, because you're jumping from -2 to 0. So that a out of this is equals a equals 1. Okay. And same thing for foci. The distance between two foci is 2c. And I can see that y coordinates are the same. So you're jumping from -3 to 1 for x, right? So the distance is 4. That's 2c. Okay, so 1c is going to be just 2. I need b, and I want to use the relationship between a, b, c. C squared equals a squared plus b squared. So in other words, b squared equals c squared minus a squared. So b then is c squared 4 minus 1. That is radical 3. Okay. So now I know ABC, I know H and K. Well, we don't know H and K yet, but we can easily find that because we have the vertices, the midpoint in between two vertices is the location of the center. And what is the midpoint? So let's just write that down here. Center is going to be, well, the distance between the two vertices is 2. Right, half of that takes you to the midpoint. So I'm going to jump from -2 to 0, but I'm going to add 1 in between. So -1 and 1 would be the location of the center. Okay, so here we go. Let's replace h and k here. So -1 and 1, and let's replace a and b here, right? A equals 1 already, so I don't need to write anything for that, but b equals radical 3. So here we go. So -1 plus secant theta plus 1 plus radical 3 secant. Oh, this is tangent theta, by the way. I'm sorry. This should be tangent. Okay, so there is a typo. I'm sure you caught it in the beginning because I copied the parametric equations wrong here, so I'm sorry about that. But this should be tangent. So you got the parametric representation of the equation of a hyperbola in part C. All right, this was a long video, and let's finish this right here. Sorry about the typo here for this one, but we got this figured out at the end. Thanks for watching. I'll see you in another video. Bye.